Okay, so today we are talking about, I am recording, finding roots, and once you have the roots, making little sketches of graphs. Let me show you an example of a problem. Y equals x minus 3, x plus 2, and let's just throw in one more x for good measure. You should be able to make a sketch of that. You should be able to look at it and say, how does this end? I know the end behavior rules. It starts with a positive number. At least there's no negative up in front, so I can assume it's positive. And that means it must be going up at the end. And since this is a degree 1, 1, and 1, add them up, it'd be degree 3. Then, since it's degree 3, it goes opposite directions like this. And then the last part is, where is it touching in between this end and this end? I mean, is it going like this and then ending going up? Or is it going like a bounce here and then it goes up? Or is it like going up as like a triple root like that? Or what is it? Well, how you find that out is you look at the factored form like we have here, and it says there's a negative 2 answer, there's a positive 3 answer for that one, and that one's a 0. It has to go through those points. Since I know it has to go through those points, I can use logic to say, well, then it has to go like that. Because that's how it's going to end up being a degree 3 polynomial. It's positive, going up on the right. And now the only other thing that we would need to figure out is what would be the y-intercept. Well, in this case, the y-intercept is really obvious. It's 0. But finish this sentence for me. The y-intercept is where what? It's a simple answer, but you're not thinking of it. The y-intercept is where x is 0. Some of you might have said that, but I couldn't hear it. The y-intercept is where x is 0. So look back at the original equation here. What if we put in a 0 here, and 0 here? Do you get that when I multiply that all out, it's going to be 0? So the y-intercept is 0 in this case. All right, let's do another one that's kind of like that. Y equals, let's put 3 up here this time, x plus 2, x minus 5 squared this time. All right, maybe a sketch of that. On the test, they will make sure you include the y-intercept and the roots, and the end behavior has to be right. In other words, if it seems like it should be going up on the right, then it better be going up on the right. This one goes up on the right. Better end that. In fact, can't we figure out the left side? Yeah, because this is degree 3. Add up those 2 powers. In this case, simple. It's got degree 3, so it's going opposite directions. Then find your dots where it touches the roots, negative 2 and 5. And then, okay. What's wrong with that? Ending wrong. So that can't be right. What's going on? What am I doing wrong? 5's got to be a bounce. How can it be bouncing there? It's still going up on the right? Oh, it can be if it goes back down through that way. There we go. Last thing is, remember that the important spot that you have to check is the y-intercept. That really helps to figure out how the middle of the graph kind of looks. The y-intercept is where x is 0. Put in the 0 here. Put in the 0 here. And then I'll have negative 5 times 2 makes negative 10. Times 3 makes negative 30. Did I do that right? Oh, I forgot to square it. That's right. All right. Negative 5 squared would be 25. Times 2 would be 50. Times 3 would be 150. Holy cow. So this is way up there when it makes its cut through, or when it touches the y-intercept. This was not high enough. And then you'd label the important spots. This one, you don't have to like scale it out and make sure it's perfect. I'm just going to call it 150. This one is 5, and this one is negative 2. Now, I've got to show you a better way right now before you start thinking that the way I'm showing you is always going to work well. There's a few trick ones that you better get used to. Watch just a small, slight change that what makes this one very deceiving. Caught me in first hour, and now I've figured out what's going on. Doesn't it seem like this one has a degree 2 because it's got, you know, 2 singles, and it is a degree 2. That's not the issue. The next part, if it's degree 2, how is it ending? Is it positive or negative in front? It's negative in front. It's positive in front. It's positive in front. There's no negative that I see anyways. And so if it's positive in front, it should be going up on the right. It should be touching at 3 and negative 3. 3 and negative 3. And now since it's an even one, you know, because it's got a degree of 2, it should be going up here also. So how can I make that work? Well, I can go like this. Doink, doink, doink. There we go. But the problem is, as soon as I stick in and find the Y-intercept, how do I do that again? The Y-intercept is where, what? X equals 0. Put in a 0, put in a 0, and then I end up with 3 times 3 is positive 9. How can my, this is a positive 3, this is a positive 3, it's positive 9. It's true. I did something wrong, and it's not the 9. The 9 is the Y-intercept. How is that possible? All right, so here's the flaw in the problem. This one, what's different about this one than all the other ones we have? There's 3 minus x. Would you agree that 3 minus x and x minus 3 are not exactly the same thing? Okay. Do you get that that's actually what 3 minus x is? Do you get how that works? Negative times the x would make negative x. Negative times the negative 3 would be positive 3. That's the same now as that. You see how there's actually a negative in front? All right, so we need a better way to handle this. And here's the other one that could screw you up. Let's say that you had one like this. You see how a kid might say, oh, degree 1, total degree is 3. Or sorry, total degree is 2. You see how they could make that mistake? What's the actual degree? Degree 3. Because this one's degree 1, but this one's not degree 1. That's what degree is in it. It's got a 2 in it, so it's a degree 2. All right, so we need a better way to handle these kind of things. So I'll throw in one that's got both of those problems. Let's say we had this. And you were asked to do this on the test. There is a great way to do this. Write this problem down, and it'll be a good one for you to put a star by in your notes because it's valuable enough. It shows you 2 important things. Do you get that if they're all multiplied out and you have like this negative 5x squared plus 2x minus 3, that you've got the y-intercept and you've got the lead coefficient right here that tells you so much? But this isn't all multiplied out. Could you just multiply it all out? Yeah, you could. But there's a faster way. Do you get that the lead coefficient right here would come from multiplying my x numbers together? Eventually, if I was going to multiply this out, those would get multiplied, wouldn't they? I mean, I'd be doing this times this, no. This times this, and this times that, this times this, and this times that. Eventually, these guys, this and this would get multiplied. And that would make the biggest term. It would make the lead coefficient. So that's what you need to do, is when you face a problem like this, you multiply out that, and you'll get your lead coefficient, because that's all you really care about. Because we can always do the y-intercept thing as where x equals 0, and it'll make those 2 terms cancel. All right, so to get my lead coefficient, for everybody, if you're taking notes, write this, lead coefficient would be this times this, which, by the way, makes negative x to the 3rd. Now, do you get that this one's going down on the right? So if I was going to make a picture of it, it's got to end going down on the right because it's got a lead coefficient that's negative. And since the lead coefficient has a 3 on it, that also tells me the degree. It's an odd one, so it must be going up on the left. One more thing. Where does it actually touch? If I put in a 5 right there, that would make it equal 0, right? Zeros are the place it touches. So it touches at 5. Going through that. Any other zeros? No, because this one, if I try to solve this, it'll never solve it because it gives you imaginary answers. Because x squared plus 3 will never equal 0. Why? Because x squared would have to equal negative 3. We'd end up with some weird, irrational, or no, impossible imaginary number. Okay. So I figured out I got to go through this. I got to be going down on the right and up on the left because this is an odd degree. What's the last thing? The y-intercept. The y-intercept is where x is 0, right? So I'm going to put a 0 here and a 0 here. Do you get how this part would just become 3 times, what's that part? 5. What's 3 times 5? 15. So it'd be up here somewhere. All right, so as long as your graph is going down, goes up through this point and up through that, and up on the left, then I'm good. The whole rest of it, don't care. I'm not going to be picky about anything except the x-intercepts, y-intercepts, and the end behavior. All right, so moral of the story. You're going to get problems like this today. Some of them are already all multiplied out, which is really neato. And because you can see the y-intercept and you can see the lead coefficient super easy and what degree it is, and these will all be really neat. But you won't be able to tell what the roots are. Like, it's really hard to know what the roots are. All right. But at least I can tell it's going down on the right because of this. And I can tell that it's going down on the left because it's even. I can tell it's got a y-intercept of 7. So it goes through that point. Other than that, I can just draw it like that. I don't know what the rest of the in-between looks like. This is important, that's important. The whole rest of it, don't care. Just going to connect the dots. All right, some of them are like this. Let's even make it -1 this time. And here's what you do. You find that lead coefficient by going this times this times this. And the lead would be x times negative x times x squared would be x to the 4th. And it's negative. Do you get now that my function's going down on the right? Is this negative right there? And it's going down on the left also because it's even. And what happens in between? Actually, I know because this is factored form. I know it's touching at 3. Let's say that's 3. Touching at 2. And it's touching at, whoa, what would that be? 1 and -1. Because do you get that x squared plus 1 or -1 factors to this? Touches at 1 and -1. That was 2, so this must be 1. This would be -1. It's hitting in all those spots. And now I can make up any story I want as long as it ends going down. And it's got a whole bunch of... There we go. Good enough. What would be the graded part? I'd look for... Oh, wait, and the y-intercept. Last thing is the y-intercept. The y-intercept is where x is 0. 0 here, 0 here, 0 here. Pretty much makes it into this, times this, times this. 3 times -2 makes -6. -6 times -1 makes +6. So I just have to, maybe I should go up a little higher on that one. Call it 6. Final answer is this black one. And I'd need to know that you knew the y-intercept, the x-intercepts, and the end behaviors. Those are the things I'll be looking for on your test. Okay. I think I've covered everything on the first part of the worksheet today. The second part of the worksheet asks you to do limit notation to describe end behavior. if I gave you this just 2 seconds ago, you should have been able to say, oh, I know. It's going down on the right because of this, and down on the left because it's even, and they have to be going the same way. So then all you need to know is that to be able to write the limits. What kind of limits are there? There's left limits and right limits. The left end limit looks like this. Limit of the function as x approaches, if it's going to be the left side, where is x? Negative infinity. So if we go forever this way, where will our function go for its y value? Negative infinity. Good. Our right end limit, I'll do in green. That's way over this way. So that's the limit as the x approaches infinity of my function will be, if I go way this way, it's going to be going way that way. Negative. Here's my right end limit. Here's my left end limit. If you're ever asked for a left end limit or a right end limit, just always start with this. And if you want the right end limit, that's way over this way, it's going to be positive infinity. If you want the left end limit, negative infinity. Now you just figure out where the graph is when you get there. Is it way up or way down? It's usually either infinity or negative infinity. All right, last kind of problem is find the zeros algebraically. The old-fashioned quadratic, 9x squared minus 3x minus 2. But I want to give you a really good way to solve these. In the past, we have said if you want the answers, you want to set it equal to 0 and either factor it or use quadratic formula, and that's true. But a lot of people are either factor people and they like to factor it and they do it that way, or other people are quadratic formula people and all they know how to do is a quadratic formula, and it's really best to be able to do a hybrid approach. Let me give you an example. They've come up with these hybrid cars because electric cars are cool a lot of the time. Like for my commute to work, it would be awesome. I'd never have to hit the gas on it. It would just be all electric. Because from my house, it's 12 miles to school. You could drive it here to school and have enough juice to be able to drive it back home again and never even use the gas. But why is a car that's only electric not very good? The range doesn't go very far. Yes. So like if you wanted to travel to great-grandma's house in Iowa, you wouldn't be able to get there. You'd get halfway there and run out. So what do? You use the gas part. The hybrid cars have some gas power and they have some electric power. So you can use the gas when you need the gas, and you can use electric when you use electric. The other thing is if they want to like shift into passing gear, I think some of these cars, when you really step on the gas really hard, it'll kick the gas engine in so that it can give you more punch for like passing. So kind of the best of both worlds is to do a hybrid. Why am I saying all this? Because I'm going to show you, now that you're all grown up and you're good at factoring and you're good at using quadratic formula, the ultimate way to solve these is to kind of do a hybrid of the two. You start with b squared minus 4ac. Because if you do b squared minus 4ac, you've done half the quadratic formula already, and if it comes out to a nice number, that means you can factor it. Because I think we all know factoring is way easier than the quadratic formula. And if you could factor this puppy down, to 9x and x and 2 and 1 and plus and a minus, if I can do that, I can get my answers really quick and easy from it. That's not the right factoring, though. So if we don't know if it'll factor, isn't kind of a pain to try to figure out will this factor or not? Well, the b squared minus 4ac tells you that. So let's start with that. What is b squared? That squared. So it would be what? 9 minus 4ac, and a is 9 and c is negative 2. So I got to multiply this out now. I have 2 negatives in there, so be careful. That's positive. And that's positive. 9 times 4 is 36. 36 times 2 is 60, 72. And then I add 9 and I get 81. What does that tell you? It's perfect square. And so if b squared minus 4ac comes out to 81, then I know this thing would have factored. At that point, you now can either continue with the quadratic formula, knowing you're about halfway done with it, Or, since it would have factored, you could go back and say, well, it's probably 3x and 3x. And then it's got to be a 2 and a 1. And then, oh yeah, I can make this on the inside negative, and that one positive, and there, I've got it. And you can get your answers that way, because now I just factored it. I can set my b squared minus 4ac aside for a second here, and say, what would I do for the answer for this? I'd say 3x minus 2 has to equal 0. So then I'd say 3x equals 2, and x equals 2/3. And this one, 3x plus 1 has to equal 0, 3x equals 1, x equals 1/3. There's my two answers. I did it with factoring. Devil's advocate, it might be just as easy to just finish the quadratic formula, because once you got this part done, now it's x equals negative b plus or minus the square root of all that stuff I already did, all over 2a. And see, I'm almost done. And negative b would be negative 3 over 2a. A was 9. So this would be 3 plus or minus the square root of 81, which I can do. Square root of 81 is 9, all over 18. And that isn't too hard to simplify from there, is it? I can just go 9 plus 3 makes 12 18ths, and 9 minus 3 makes negative 6 18ths. And those are my two answers. They just aren't reduced all the way. Which way do you like? Hey, it's your call. Do what you want. You can still just be a factoring person and always try to factor them. And Mrs. Richards makes our tests, and she likes things that factor, so a lot of times they do factor. But they don't always factor. Sometimes you'll be farting around for 20 minutes trying to make something factor, and it doesn't. That's why doing this b squared minus 4ac part first is smart. Because if it comes out to a nice number, you know it factors. If it comes out to a not nice number, you know it would have never factored, even if you took 20 years to do it. At least it wouldn't factor with nice numbers. It might factor with imaginary numbers, which is a whole other story. So anyway, start with b squared minus 4ac. Unless you just want to always factor them, or you just want to always use quadratic formula. It is true. Quadratic formula will always work. It's just sometimes long. So, all right. Now I've showed you everything you need to know, but I want to do like one of the problems of each kind off this worksheet with you. So, here we go. This is your worksheet for today. Oh, do I want your homework? Yes, we got this, we graded them, so I will ask you for those scores to put into the grade book in a moment. Sketch. All right, let's do the first one together. Numero uno. You know what? Number one's too easy. I'm going to go to number 2. Number 2's got one of those little twists in it. It says f of x. You get to do number 1, but it's really easy, so just do it later. 2x minus 3 and 4 minus x. There's the twist right there. And x plus 1. This way I showed you today of multiplying out all the x parts, that, and that, to get the lead coefficient is a pretty smart way to do it. Just like that hybrid thing, it's kind of the state-of-the-art best way. This is the best way. You could say it's degree 3 because these are all degree 1s, but it's going to be really easy to forget that this one's negative in front because of this weird little twist. So multiply this times this times this, and you'll get 2x to the third, and it's negative. So you get my lead coefficient now? So what does that tell me about my graph? It tells me it's going down on the right. And that's telling me that the ends have to go opposite directions because it's odd. So if it's going down on the right, the other part of this homework is to make a sketch of it, so you can start making the sketch too. Down on the right goes like this. And it's going up on the left. And then where does it touch? It touches in like that. One little quick commercial. Any of you that are interested in taking the ACT soon, I am doing an ACT review tomorrow morning in room 1602 in 0 hour. So if you want to see what the ACT is like, I'm going to be giving a bunch of tips and stuff. here at school during 0 hour. Normally I have meetings on Wednesdays. This is my thing. I'm doing this Wednesday. Okay, so this one, you have to figure out what this would make it 0, and it would be 4. So this has to go through at 4. This one would be -1. And this one's a little harder. I'm going to go off to the side and solve it. 2x minus 3 has to equal 0. 2x has to equal 3. X has to equal 3/2, which would be the same as 1.5. So there's, right there is 3/2. These do not have to be super accurate. Alright, generally this thing's going down on the right. So I'm going to go down like this. Are there any bounces that you can see? Nope. So these probably are all just cut throughs, so it's probably just going to go like that. And what's the one thing I haven't checked that I warned you I am going to check? The Y-intercept. The Y-intercept is where x is 0, so put in a 0 right here and here and here. Do you get that that pretty much cancels out all the x's and all I'm left with is these other things? 1 times 4. Notice the negative is not on the 4. 1 times 4 is 4, and 4 times -3 makes -12. So this really should have gone lower. But if I just label it -12, I'm okay. All right, so we're checking for the roots. We're checking for whether it's going up and then down. And we're checking for the Y-intercept. All the other points are kind of like superfluous. How do you say that correctly? Any English majors in me? Is it superfluous? Is it superfluous? Right. All right. Let's do another problem. That was number 2. Let's 1, 2, skip a few over to number 13. Number 13, it wants the end behavior using limit notation. I can tell you what the answer's got to start with. Lim of the function as x approaches infinity. Is that the right side or the left side? That's the right side. And I'll figure out later where the right side's actually going. And then there's the left side. Lim of the function as x approaches -infinity. Okay, so this is the right. And this is the left. And on the right side of that one on number 13, the lead coefficient was -x cubed. The lead term, I should say. And so the negative tells me it's down on the right, which would mean -infinity. And then since it's an odd one, they have to be going opposite directions, which means it has to be up on the left. And up would be synonymous with infinity. There we go. And the last kind is 15 through 18, where they asked you to find the zeros of the function algebraically. I think they already did number 15 for you. 9x squared minus 3x minus 2. Remember that one? That's the one where I said, what's this new way I'm telling you is a great way to start? B squared minus 4ac. So b squared would be 9 minus 4 times a times c. A is 9 and c is -2. Final answer on that would be 81. So b squared minus 4ac is 81. That tells me it factors. So you may want to factor it. Or maybe you're the type who's just like, you know what, I'm already most of the day done with the quadratic formula. I'll just finish that. 3 plus or minus the square root all over 2a. 2 times 9 would be 18. If you just simplify that, you'll have it. This was b squared minus 4ac there. I think in this case, I'd probably just go, even though it came out to a nice number, I'd probably just still finish with the quadratic formula. All right, this homework is a little long. I'm going to have you skip a couple. You may skip numbers 5 and 8. That'll save you some time. One of those was nasty. Number 5 and number 8 you can cross off. The rest of them are assigned. You got 12 minutes left in class, something like that. And that's the end of the video.